Um, Dr. Savinder, I think we can start now. It's already 11:06. Maybe some students will join.
Yes, sir. Yes, sir.
Yes, sir.
We can start, sir. Dishan,
Good
sir,
morning, Dr.
please
Swarnendu.
start.
A very good morning to everyone. Good morning, Dr. Swarnendu. I welcome you all in the second session of our skill data handling using software packages from analysis to presentation. I welcome our second speaker, Dr. Swarnendu Rao. Now I invite Dr. Savinder to introduce our speaker of the day and further proceeding. Over to you, sir.
Thank you, Dr. Ishan. A very good morning to all who are present here. It is my distinct pleasure to introduce our esteemed speaker, Dr. Swarnendu Roy, a distinguished academic whose contribution to plant science and stress physiology have been both impactful and inspiring. Dr. Roy is currently serving as assistant professor at the University of North Bengal, Siliguri, India, a position he held since December 2018. His teaching career span over 13 years. An exceptional scholar from the start, Dr. Roy was awarded the University Gold Medal for securing the first position in BSc and the University Silver Medal at the MSc level. His academic brilliance earned him the postgraduate merit scholarship from the Ministry of HRD and UGC and the prestigious CSIR JRF for his doctoral studies. During his PhD, Dr. Roy conducted groundbreaking research on stress physiology in rice and salt tolerance grasses, notably submitting the first ever cDNA sequence of NHX and SOS1 gene of cyanidone dactylone to NCBI. His current research encompasses diverse areas from salinity stress in cereal and legumes to nanoparticle mediated stress management and multiomics investigation on azola's response to environmental contaminants like BPA and heavy metal. He is guiding 8 PhD scholars, two of whom have already submitted their thesis and has mentored several MSc dissertations. Dr. Roy is widely published over 50 research articles and book chapters and has served as editor of 4 scholarly volumes, including titles with Springer, CRC Fresh, focusing on plant stress, microbial symbiosis, food safety, and nanotechnology in agriculture. Internationally, he was supported by the DST government of India to present his work at the International Conference in Spain 2019. He is a life member of several prestigious scientific societies, including the Indian Science Congress Association, AFSTI, and the Society of Plant Research. Notably, he received the Young Scientist Award in 2023 from both the Society of Plant Research and Veritas at SKA Kashmir. Please join me in welcoming Dr. Swarnendu Roy, a researcher mentor and thought leader whose dedication continue to shape the future of the plant science. Over to you, Dr. Swarnendu. Thank you.
So thank you very much for the introduction. Good morning to everyone. And I'm indeed grateful to Dr. Savindra Kumar for inviting me for this particular talk. Though I belong to the plant science background, but as a researcher and as a guide, we always need to use the basic tools of the statistics. And the statistics is a very important subject. And we are basically afraid of statistics, but we also need to use the statistics in every research and developmental works. So as a result of that, I would like to prefer to call myself as a learner of statistics rather than an expert of statistics. So, sir, I believe that the candidates or the participants are basically from the UG and PG background.
Yes, sir. Majority of them are UG and PG, but there are many faculty member and research
Okay.
scholar as well.
Okay, sir. Thank you.
But majority of them are undergraduate.
Okay. So, sir, can I start with my presentation?
Yes, sir. You can share your presentation.
Okay. So I will just switch off my video and start sharing my screen. Sir, that screen sharing mode is turn off. It is showing that you can ask the meeting host to turn on screen sharing.
Dr. Ishan, please check this issue.
Yes, sir. I'm working. Please check. Is it working now?
Now paired with. Still, it is showing the same thing that you are not allowed to share your screen.
Okay. Okay. Please check now.
Now it has come. Is it visible?
Yes, sir. Your screen is visible, but earlier it was showing some screen, but right now it is only blank.
Oh, it is blank.
It's better to share the entire screen and then open your presentation.
Now I think it is visible.
Yes, perfectly, sir. Perfect.
Okay. Okay. So the topic of my lecture today is the descriptive and inferential statistics. So first of all, I would like to thank the organizers at the Zakir Hussain College, University of Delhi, for organizing this skill development and learning course for the students and the faculties. And basically, I am working as an assistant professor in the University of North Bengal in the Department of Botany. And I've been doing some research in stress physiology and mostly with the plant growth and development and some ecotoxicological studies. And the thing is that all of us who are doing some research in plant sciences or any of the other sciences, the geological sciences or any field, we basically require the use of statistics. And in this connection, uh, most of us are afraid of this particular discipline. And in most of the cases, we often face the confusion that when to use a certain statistical tool and how to apply that particular statistical tool and how to infer a meaningful result or a meaningful interpretation of our data. So that is the problem most of us actually face. And in this connection, I would like to start with the very basics of the statistics. And after that, I will slowly be moving on to the different tools. And with some examples, I would like to explain that how we can use these particular tools for solving our own problems in our research and developmental field. So basically, as a discipline, statistics is the science whereby inferences are made about specific random phenomena. And it is basically a science that is used in our day-to-day life without our knowingly or unknowingly. So whenever, if you can take the example of that means visiting a market and doing a survey of the market regarding the cost of a vegetable or cost of any product. So basically, whatever we do, we visit 2 or 3 stalls or 2 or 3, go to the different shops, and then we negotiate the price of the commodities. In that way, we are doing the surveying, and after the surveying, we try to compare the rates of the different shops, and after that, we come to a conclusion that whether the rate is lower in a particular shop, whether it is higher in a particular shop, and also we get a overall knowledge about the average price of this thing. So this amount of statistics every day we are using in our day-to-day life. So basically, if you see the field of statistics, it can be basically divided into 2 broad categories or broad fields. One is the mathematical statistics and another one is the applied statistics. So in case of the mathematical statistics, so this is basically the hardcore subject of the statistician, which are actually involved in developing the different tools, developing the different algorithms for creating or for developing different statistical tools that we have to use for the inferential statistics. So basically, you can see that the mathematical statistics, it is basically concerned with the development of new methods of statistical inference, and it requires the detailed knowledge of the abstract mathematics. So as a student of the plant science or the biological sciences, we are basically not concerned about the mathematical statistics, and rather we are dependent upon the applied statistics, which basically involves the use of the particular tools and algorithms that are developed by the mathematical statisticians. So if you see the field of applied statistics, it involves the methods of mathematical statistics and applying that methods to specific subject areas such as economics, psychology, and any field that you can name, starting from the medical sciences to the biological sciences, plant sciences, animal sciences, etc. So basically, I will be discussing about the biostatistics. So if you the literal meaning of the biostatistics is basically the biological statistics, and sometimes it is also referred to as biometry. So this biostatistics, it is a specific branch of the applied statistics, and it applies the statistical methods to the medical and the biological sciences. So in case of the statistical methods or biostatistician, they are involved with, first of all, designing the studies for their solving the problems, then collecting the data by sampling and surveying, and then presenting and summarizing the data and drawing meaningful inferences from the sample data to a population. So basically, the biostatistics, it aids the administrators, legislators, plant managers, and the researchers in answering the questions. Now, one of the basic prerequisite of doing a statistics is to have a good amount of data or a very reliable data. So data is the key for any of the statistician. So you can see, so what is the data? So data in biostatistics are generally based on the individual observation, any type of observation that are being made from the population or any sample that consists of the data. So this data is in biostatistics is very, very important. So that means you should have a data prior to applying any type of biological or any type of statistical tools for deriving some meaningful interpretation. So these data are observations or measurements that are taken from the smallest sampling unit. So this smallest sampling unit is very important because whenever you are going to sample some population, or whenever you are going to collect some data from the population, having the smallest sampling site is unit is very important, and determining this smallest sampling unit is very, very important for the purpose of a statistician. Because if you want to draw a meaningful interpretation from the population, suppose you want to collect the annual income of the household of a particular block or a particular subdivision. In that case, it is not possible to go to every individual your household and collect the data. So in that case, there should be a random sampling, and the number of the household that is required and that can give you the possible interpretation of the entire population in that particular block is considered as the smallest sampling unit. Another thing is that the data point. So what is data point? Data point is basically any type of record. It may be a descriptive account. It may be a symbolic representation of the attribute. It can be any event. Data are usually measured, either it can be measured in a numerical scale, or it can be classified into your categorical or numerically coded your data. Now, so I have already told you that data is very important. Data is the central core for the statistical your interpretation. So in this case, the data accuracy and precision is important. So what is the literal meaning of these terms, accuracy and precision? Accuracy is the closeness of a measured or computed value to its true value. And precision is the closeness of the repeated measurement. So that means any two individuals, if any two individuals are given the task for collecting the data from the same population and deriving some interpretation regarding the, suppose the example that we have taken, that is the annual income of the household. If both the individuals, they get the same type of result or the close result, so that represents the accuracy of the data. And what is precision? That means if you conduct the same experiment again and again and you get the same type of result, and if the results are very close to each other, that represents the precision of the data. So in any case, the accuracy and the precision of the data is very, very important for conducting a statistical interpretation. Okay, if in any of the particular slides, or if at any particular moment, if you have any questions, you can stop me and you can ask.
They can ask, otherwise in the end we have a question answer.
We can have a question answer, and if in any particular moment if they feel that they want to ask something, they can ask. Otherwise, we can go, and after that, at the end, we can have the questions. Okay, so there is another important terminology, that is the variables. So the observations and the variables. So what is an observation? Observation is basically the collection of the data from your sampling unit. So the actual property that is measured by the individual observation is the character or the variable. So whatever data that is collected from the sampling unit or the population is basically the character or the variable. So in statistics, we observe and measure the characteristics called the variables of the study subject called the observational units. So each and every individual is considered as the observational units, and the characteristic that are measured is basically considered as the variable. So in any case, you can see there are different type of the variables depending upon the nature of the data, depending upon the nature of the observational unit. The variables can be differentiated into either your nominal variable, ordinal variable, interval, and the ratio. So there are some differences between this nominal, ordinal, interval, and the ratio variables, and they also represent the different levels of the measurement. So in case of the nominal, the terminology it derives from the your nominal means the name. So that is they are basically the named variables. In the named variables or the nominal variables, we do not have any order. For example, the boy and girl, men, women. So these are basically the nominal variables. So basically this data or these variables, they directly do not have any numerical attribute. So that is why they are nominal and the ordinal variables, where there are no direct numerical attributes associated with this type of variable. Next, there are two types of variables, that is your interval and the ratio variables. And this interval and the ratio variables, they basically refer to they can be basically variables, ordered variables, proportionate and interval between the variables are there. and they can also accommodate the absolute zero. So you can, if you can see the examples of this, in case of the nominal scale, so either they are basically the dichotomous type of your variables, either A or either B. So this nominal scale, it is used to label the variables in different classification and does not imply a quantitative value or the order. So there is no quantitative value, there is no order of the variables, either A, either B, like this. So you can take the different example like yes, no, boy, girl, men, women. So these are the examples of the nominal scale. In case of the ordinal scale, you can see they are associated with there is a specific order of this particular variable. For example, you can see that the frequency, the satisfaction, happiness. So this is just just the example you can take, that is the feedback. In case of the interval scale, you can see that there is a basic order of this, the order is there, and some numerical attributes are also associated with this particular order. So this is basically the interval scale. So the same thing is there. That means the satisfaction, happiness, degree of pain is there, but they are ranked from 1 to 7. So in some cases, the 1 may represent the lowest point, 7 may represent the highest point. In some cases, the 1 may represent the highest point and 7 may represent the lowest point. And in case of the ratio scale, you can see that there are some ranges, that how many, you can see the example that how many hamburgers can you eat a day. So that means 1 to 2, 2 to 3, 4 to 5, more than 5. So this is an example of the ratio scale. There are also numerical attributes associated with this particular scale. And also there is an absolute zero. That means you can also may not have eaten any of the hamburgers in a day. So the variables are also associated with that means you have information about the value of the true zero. But in case of the rating of your experiences, you do not have any absolute zero in this type of your interval scale. Now, so this is basically the same type of classification of the variables. So if you want to classify the variables, you can see that this nominal and ordinal, it represents the categorical variables, and the numerical variables is another type of the variable. And in case of the numerical variable, there are some discrete numerical variables can be differentiated or categorized into two subtypes. One is a discrete variable, one is a continuous variable. So what is an example of the discrete variable? Example of a discrete variable will be the age of an individual, or the weight of an individual. So that is a discrete interval. And continuous variable, that means there are some continuous numerical attributes in this type of variable, which can be subdivided into your interval and the ratio scale. So these are the classification, broad classification of the variable. Now you can see these variables can also be categorized in some other way. In case of your experiment, or whatever experiments we conduct in our research and developmental purposes, in this case there can be some other type of variable except the variables that we have discussed. So one of the simplest examples, these terminologies you may be aware of, that is the independent variable and the dependent variable. So what are the independent variable? Independent variable is the variable or the factor that you can change in your experiment. And the dependent variable is the variable that you measure in your experiment, and which depends upon the change in the values of the independent variable. So that means depending upon the factor which affect each other, one of the variable can be independent and one of the variable can be dependent variable. So examples you can see that in this particular example, so the basic objective was to observe the effect of caffeine on the number of words you remember. That means the memory, on the memory. So you can see that the dependent variable example is number of words recalled, so that you can measure. And this dependent variable is dependent upon the whether you have consumed the caffeine or not. So that is your independent variable. So that means the factor that you can change. So either you can give your 1 cup of coffee, 2 cup of coffee, 3 cup of coffee, and after that you can observe the effect of this particular variable on the dependent variable, that is the number of words recalled. Again, you can see there are some control variables. That means the factors you hold constant. That means some of the factors you can hold constant. That means the amount of the caffeine and the source of the caffeine. So this can be constant variables. So that means they do not change with the experiment. So in any case, whether you change the independent variable, these variables will be unchanged. So these are known as the control variables or the constant variables. And there is another type of variables, that is the confounding variables, or basically the hidden variables that might affect the results. So these are also known as the extraneous variables, or the variables or the factors that you do not know, or that you cannot predict from the the beginning of the experiment, that whether they are going to have any effect on the outcome of the experiment. So in this case, you can see that some examples of the confounding or extraneous variables are time of the day, caffeine sensitivity. So this can be the examples of the your extraneous variables. So that can have an effect on the experiment, but you have not considered in your particular experiment. Now let us come to the topic of our today's talk, that is the descriptive statistics and the inferential statistics. So before going into the details of this particular topic, first of all, let us understand that what is the difference between the descriptive statistics and the inferential statistics. In both the cases, they are actually meant to simplify the data that we have collected from the population. So one thing we have to understand that the population represents the number of the individual living in a particular location, geographical location, that can be associated with some geographical location, or it can be associated with some specific area or a specific unit. For example, the number of students in a class, you can consider that as a population also. So number of students in a class, if it represents the population, and if you want to study, suppose the average height of the students in your class. So suppose if there are only 30 students, then it is very easy to actually measure the height of each and every student and then come to a conclusion. But if the number is 2000, if the number is 3000, suppose the height or average height of the students in a school, if the number is 3000, 5000, more than that, then what happens? It is not possible, and it is not logical also to measure the height of each and every individual. In that case, the one of the first prerequisite is to do a random sampling. So that means you have to randomly select the individuals from the population, and when you select the individuals from the population, that represents your sampling unit. So there are different methods by which you can do sampling, and I know that you have one lecture on the sampling and surveying. So in that you will be getting the details, or get to know about the details of how you can perform the sampling and surveying. So basically, population is the broader unit. From the population, you select some small individuals, or select some small observational unit that represents the sampling unit. And when you have collected the sampling unit, so basically you can perform, very simply, you can perform the descriptive statistics. That means the mean, median, or the mode. So this type of statistical analysis, it represents the descriptive statistics. Descriptive statistics means when you are performing some numerical analysis with the data in your hand. So the average of the class, it represents the descriptive statistics. But it does not tell you that whether the average height of the individual is greater, that means whether the average height of the individual, it can represent the actual height, or it can represent the majority of the height of the population or not. So for that, actually, you have to perform the inferential statistics. The term inferential statistics, it is derived from the inference. So inference means when you can draw a interpretation from the statistics, when you can draw an interpretation upon the descriptive statistics. So that means, first of all, the basic statistical analysis that you perform is basically the descriptive statistics. And after that, when you want to infer some other interpretation, when you want to derive some other meaningful conclusion from that particular data, it represents your inferential statistics. So you can see that in case of the descriptive statistics, there are some steps. That means first you organize the data, then you summarize the data, then you simplify the data, and then you describe and present the data. So this description of the data, from that the terminology has been derived as descriptive statistics. So when you describe the data, how you can describe the data? Either in numerical attributes, either you can describe the data in your tabular form, either you can describe the data in your graphical form. So that means which is associated with the visualization of your data. For that, you may have to use different type of statistical tools, either your Excel, R, or Spaces, or different type of software you can use for your graphical and tabular representation of the data. So the descriptive statistics, it only deals with simplifying the data. So whenever we do some statistics, our objective is to simplify the data, or our objective is to actually give a simplified, meaningful interpretation of the data that you have collected. Now, when you come to the inferential statistics, so this inferential statistics, it follows the descriptive statistics. That means whenever you have some description of the data, and after that you want to derive some other information, or you want to derive some conclusion regarding the data, that whether the data you have collected is proper or not, whether it represents the entire population or not, whether it signifies a small section of the population or not. So in that case, you have to generalize the descriptive data, and you have to apply some different type of your statistical tools for deriving the meaningful interpretation. So in this case, the first step to generalize from the samples to the population. So that means whatever your description of the data you have collected, so you have collected the mean, median, mode of your sampling unit. So then you have to apply that particular information to the population. That means when you are drawing some conclusion of the population using the data points of the sampling unit. Okay, so then you have to perform some hypothesis testing, and after using some different statistical tool, you can make the prediction regarding the type of the data set you have in your hand. So this is basically the difference between the descriptive and the inferential statistics. So you can see that the purpose of the descriptive statistics is to summarize and describe the data. The purpose of the inferential statistics is to draw conclusions about the population. And in this case, the data used is the entire population or the sample. In case of the descriptive statistics, if the population size is small, you can measure each and every observational unit or each and every individual. But if the population is large, you have to draw a sampling unit from the population. And the inferential statistic, basically it is dependent upon the descriptive data. So that is why it is always dependent upon the sampling unit. So you can see that the different statistical tools that are applicable in case of the descriptive statistics are the mean, median, mode, and the graphs, or the tables and the graphs. In case of the inferential statistics, you might have heard about this term, that is the t-test, p-values, confidence intervals. So this type of statistical tools are basically used for the inferential statistic to see whether the data that you have derived is significant or non-significant. So the significance and the non-significance of the data, or differences in the mean, are basically different, dependent upon the p-value and the confidence interval of your inferential statistics. So in this case, the key questions that we can ask in the descriptive data is that, what does the data tell us? That means, what does the data tell us about the population? That if you want to ask about, what can we infer about the whole population? So basically, when you infer only about the sampling unit, it is associated with the descriptive statistics. When you want to infer some interpretation about the whole population, in that case, it is associated, or it can be categorized under your inferential statistics. And the certainty is not there in case of the descriptive statistics, and in case of the inferential statistics, it can tell you that whether the data or whether the result that you have obtained is certain. That means you have to apply the different laws or different your analytical techniques of the probability. You have to use the laws of the probability, and with the certainty you can tell that whether the data is giving some meaningful interpretation or not. Okay, so first of all, we will discuss a little in detail about the descriptive statistics. So you can see there are different ways by which you can perform the descriptive statistics. One is the measure of the central tendency, which basically can be done with the mean, mode, and median. One is the measure of the variability, so which deals the variance, standard deviation, interquartile range. One is the distribution shape, that is the central limit theorem, skewness, kurtosis, and then the tables and the graphical representation of the data. So the summary tables is basically the frequency distribution table, and the graphical visualization, there are hundreds of different ways by which you can graphically represent your data. So these are the most common types, that is the bar chart, histogram, pie chart, box plot, scatter plot, and violin plot. Apart from this, there are other types also nowadays for representing or graphically visualizing the data. So first of all, we will start with the measures of the central tendency. And as all of you know, that the measure of central tendency is basically associated with determining the centralmost point of a particular data set. So that means why it is important? Because when you have different data points, for example, suppose you have 100 of different observational unit, and the same example you can take, that is the weight or the height of the students, 100 students. So in that case, all these different data sets, it is very difficult to actually tell that these heights are the heights of the different individuals. So in that case, if there is one single point which can have a which can represent the entire data set, that is always desirable. So for this purpose, different measures of central tendency has been proposed, and in this case, the mean, median, mode are the most important. So you can see that these measures of the central tendency is basically the simplest descriptive statistics that can be useful in drawing, useful in data editing, as well as in aiding our understanding of the data. So the minimum and the maximum values of a variable are useful statistics when editing the data. And basically, this is the statistics of the location. That is why it is known as the measures of the central tendency. So the main objective of performing the or determining the location is to describe the position of a sample along a given dimension representing a variable. Go by this complicated your definitions or complicated your language. So if you want to understand that what is the central measures of the central tendency, or what, so this measures of the central tendency is basically deriving a single most point or deriving a single most value which can tell you about the entire set of the data, that is the entire data set. Okay, so first we will discuss about the mean, so the arithmetic mean, and there are other type of means, that is the geometric mean and the harmonic mean, apart from the median and the mode. So this arithmetic mean and median and the mode are the most commonly used measures of the central tendency. Okay. Can any one of you tell that is there any difference between average and the mean? Anyone, any participant? What is the basic difference between average and mean?
I think they want to listen from your side, sir.
Okay, no problem. So basically, the average is average. The term average is used by even the layman. They are using the term average. That means average basically means the mean. So, but not always. The average is basically the arithmetic mean, not the geometric mean and the harmonic mean. So that is why in most of the cases, whenever we use the term average, it represents the arithmetic mean, but the mean is always not a average. So what I mean to say that the average is equivalent to the arithmetic mean, but it is not equivalent to the geometric mean and the harmonic mean. So that is why we cannot say that mean is equivalent to the average. Okay. So this is the basic difference between the your average and the mean. So one of the most commonly used mean, that is the arithmetic mean.
Sorry, sir. Can I interfere, sir?
Yeah. Okay.
Okay, so I just have a query because I have seen that they are also known as average of position, and we generally call it median and mode. So it means, as per your information, that average means arithmetic mean only.
Arithmetic mean and average, they can be synonymously used. Basically, the average terminology, if you see mathematically, you just add up all the values and divide by the number of the observation. So that is equivalent to the arithmetic mean. But in case of, if you want to equilibrate with the median and the mode, so that is basically not the average. And also the geometric mean and the harmonic mean, which are the other two different variants of the mean, they are also not equivalent to the average. So that is why the average, it is synonymously, it is basically the arithmetic mean. Not, it cannot be, you cannot say that average is a mean. So often, very loosely we say that average is mean, but average is basically the arithmetic mean. So that I wanted to say actually.
Okay, thank you.
Okay, so you can see that the arithmetic mean, it is commonly, it is referred to as the mean. Very loosely it is referred to as the mean or the average. And basically all of us know that how to calculate the mean. So it is calculated by summing of all the individual observation of the item and dividing by the number of the items of the observational unit. So this mean, or the single most value that we derive, it is basically used to represent the entire data set. So that is why it is called the measures of the central tendency. Now, so these are just the mathematical, mathematical representations, or how you can calculate. So I will give you the presentation. You can go in details through the presentation. But for the simple terms, you can see that these are the values 8, 5, 4, 12, 15, 5, 7. You add up all the values and divide by the number of the values. So you can count the number of values 1, 2, 3, 4, 5, 6, 7. So it is simply the arithmetic mean. So similarly, in case of the, there are two types of data set. One is your either the data set if the number of data point is very less. Just we have taken this example, the number of data point is 7. In this case, we can directly add up all the values and divide by the number of the observational unit. So this will simply give you the arithmetic mean. But if the number of data points are high, suppose more than 100 or 1000, so in that case, it is not possible to add up all the values. Though it is possible, but in that case, what we perform, we try to actually prepare a frequency table. That means we try to prepare the class interval depending upon the spread of the data set. And accordingly, you can see that this represents the class interval, that is 10 to 19, 20 to 29, 30 to 39. And after that, we take that means the midpoint of the first interval. So basically, the actual midpoint is 9.5 and 19.5. So in this case, the actual boundary is not defined. So basically, the actual boundary is 9.5, 19.5, and in this case, it is 19.5 to 29.5. So like this. So this is the actual boundaries of the classes. So here, basically, when we prepare this type of the frequency table, so here we are simplifying the data set with the objective that we do not want to add up all the individual data points. So in that case, what we perform, we first prepare the class interval like this. And after that, we count the number of the data points that are present in that particular class interval. So like this, we can count the number of the data points. And you can see this will add up to the number of the observational unit that you have taken in your data set. So this is the frequency. So this is the summation of the F, that is the frequency. And these are the individual midpoints. So individual midpoints is basically found out by the subtracting the upper bound of the class interval and the lower bound of the class interval and dividing by 2. So that is 19.5 plus 9.5 divided by 2 that we have seen in the previous slide. So this is the actual midpoint of this particular class. So like this, we calculate the actual midpoint and then we find the product of the frequency and the midpoint like this. And after that, we find the mean by using the formula summation of Fm by summation of F or N. So here the N is 57 number of observational unit, or it can also be represented as summation of F. So this is the simple formula of the arithmetic mean, that is the summation of F by summation of F or summation of F by N. So this will give you the mean value in case of the group data. So I think that you can now clearly distinguish between the grouped and the ungrouped data. So the grouping of the data is actually done to simplify the data set. So now let us come to the geometric mean. So in any case, so what you have seen that the mean, it represents the average. So you simply add up the data. But when to use the geometric mean? So this geometric mean is used in other purposes or in other circumstances. Basically, when you want to calculate the average growth rate over the multiple periods, such as the compound interest or population growth over a multiple period, or the geometric mean, it provides a more accurate representation than the arithmetic mean. So in certain cases, the arithmetic mean, it cannot provide you the correct interpretation or correct location of the central tendency. So in that case, in samples that we have taken, suppose suppose you have invested 100 rupees and in the first year you make a profit of 10%. So your 100 rupees will become 110. But in the next year, you make a profit of, you make a loss of 1%. So in that case, the loss will be on the 110, not on the 100 rupees. So in that case, calculating the average or calculating the mean by the simple arithmetic mean is not possible. So in that case, you have to use the geometric mean. And why the term geometric mean has arrived? Because it has arrived from the averaging of some of the geometrical problems. So one of the example that you can take is the rectangle. Suppose you have a rectangle of two sides, that is your length and breadth of 4 and 2. So in that case, if you want to find the average or if you want to find the mean of the sides of the square, which can give you the same area, so in that case, you can find out the geometric mean of the length and the breadth of the rectangle. So this is one of the simple example, and that is why this type of mean is referred to as the geometric mean. So here you can see that in case the variables are sometimes logarithms in basically the geometric means are transformed into logarithms of the in this case if you calculate the means of such transformed variables and then change the mean back to their original scale, this means will not be the same as if we had. So that means you can see that if you can using the same data and the geometric mean of the same your observational unit of the same data, so this will give you the different results. And in certain cases, the cases that I have mentioned, in that cases the geometric mean will be more appropriate location of the central tendency compared to the your arithmetic mean. So that is why we perform the geometric mean in certain cases. It can be substituted by the pi. So this pi, it represents the product. So you can see geometric mean can be found out, or it can be represented by the nth root of the product of the y variable. So this is the formula of the calculating the geometric mean.
Sorry, sir, to interfere.
Ah,
Actually, I want to say that all these topic will also be covered in the detail in
okay.
upcoming session. So you
Okay,
can
sir.
superficially touch that and
I will not go into the details of the that mathematical formula and all.
yes,
Just the differences I will be focusing on.
yes, sir, yes.
No
Thank you.
problem. So now let us come to the harmonic mean. So the harmonic mean is basically it is best for averaging the rates, ratios, or speeds. So whenever you are dealing with the speed of something, a rate of something, then you can use the harmonic mean. So this harmonic mean is basically derived from the different in the musical your notations. You have seen that different notations are there. So in that case, this terminology has been derived from that, where you can take the reciprocal of the arithmetic mean. So this harmonic mean is basically the reciprocal of the arithmetic mean. So you can see that the formula just the reciprocal of the arithmetic mean is actually represented by the harmonic mean. Now, the median, which is also a measure of the central tendency. So here, in case of the median also, you can see that when you have a data set like this, 8, 5, 4, 12, 15, 7, and 28, so this median, basically, it represents the centralmost data point that is present in the data set. So if you have a odd number observation, it is very simple to calculate. That means in this case, you can see 1, 2, 3, 4, 5, 6, 7. So if you have 7 number of observation, so the fourth point or fourth data will represent the median of that particular data set. So the only thing you have to do is you have to arrange the data in your ascending or the descending order. So in the simple terms, if you have an odd number observation, it can be easy. It is easy to determine the centralmost position. But in case of the even number observation, there are two centralmost positions. So in that case, you have to find out the mean of that two centralmost data points. So this will give you the median. So this is also one of the way by which you can locate the centralmost point of the data set. But there are some disadvantages of the median. So you can see that it takes no account of the precise magnitude of most of the observation, and it is therefore less efficient than the mean because it wastes information. So that means if you see that you have taken a data point, suppose if you in this particular data point, if you take one data point which is 200. So this 200, it does not, it is very far away from the entire data set. So in that case, the entire data point or it cannot locate or it cannot tell you about the exact centralmost location of your median. So that means having a outlier. So this type of data points which are very distinct from the basic data set. So this type of data point can be considered as the outlier. So that means adding one outlier can entirely change the meaningful centralmost location of the when you want to represent that data point with the median. So now you can see that other disadvantages. That means if two group of observations are pooled, the median of the combined group cannot be expressed in terms of the medians of the two component groups. So that means pooling of the data, it will also change the median. And in case of the large data sets, the median requires more work to calculate than the mean. And it is not much used in the elaborate statistical techniques. So that means this median, it has some of the disadvantages considering or comparing that with the mean. Now, there is another way of measuring or locating the centralmost point of the data point, that is the mode. So mode is simply the the value that is repeated the most number of times in the data set. So you can see that the mode is the most frequently occurring value among all the observation in the table. So it can be unimodal, it can be bimodal, or bimodal, or what is antimode? Antimode is basically the reverse of the mode. So that means whenever you get a U-shaped curve in the your distribution table or the histogram, so that particular U-shaped point is referred to as the antimode or the reverse of the mode. So this is basically the distribution of a normal distribution table. So this whenever you have you collect the data set, so your data point should ideally come as a bell-shaped curve. So this is the bell-shaped curve, and where the mean, median, and mode can have different values. So more the mean, median, and mode are closer to each other, the more the data is properly distributed in the normal distribution. So I'm not going into the details of this. That is the mean for the group data and the how to calculate the median. So all the formulas are there. So I will share the presentation. If you are interested, you can go through it. That how to calculate the mean, median, and mode from the group data. So these are the formula. And there is another terminology, that is the interquartile range. So what is basically the interquartile range? So that means if you divide your data set into 4 quarters. So 4 quarters means, so that means suppose one data set is having data points from 1 to 100. So that means maybe some point is 5, maybe some point is 10, 15, 25, like this. If you have a data set like this, which ranges from 1 to 100, so you can divide this data set into your 4 quarters. So 0 to 25, it represents the first quarter. Then 25 to 50, it represents the second quarter. Then 50 to 75, it represents the third quarter. And obviously, the fourth quarter is represented by the 75 to 100. So in that case, if you can determine the first quarter, it will give you the intermediate point between your first quarter and the second quarter, if you determine the Q1. If you determine the Q3, it will represent the data point at the intersection of the Q3 and that means the third quarter and the fourth quarter. And the Q2 is basically the median. That is the midpoint or the centermost location of the data point. So like this, you can calculate the interquartile range, and this can be represented in the form of the box and whisker plot. So this is known as the box and the whisker plot. So this is basically the Q1, this Q2 is the median, and this is the Q3, and these are the 4 quarters. So that means it represents the 0 to 25% of the data point. It represents the 25 to 50% of the data point. It represents the 50 to 75. It represents the 75 to 100. So, and this particular point or this particular elongated region is known as the whisker. So these are shown as the whisker. So this is the Q1. So that means using this formula, you can calculate the Q1 and the Q3 and the median also, and you can plot this data point in the form of the box and the whisker plot. So which is most commonly used method of interpretation, or most commonly used method of displaying the data whenever you perform the descriptive statistics. Now, this also you can see that these are the formulas for the calculation of the mode in case of the group data. So in case of the group data, you can, first of all, you have to prepare a frequency table like this. And from the frequency table, you can use this particular formula for the calculation of the mode. So now the mode is from the histogram. So I will be discussing about how to, when we discuss about the different methods for describing or presenting the data in the tabular and the graphical representation, you will see that how the histogram is actually drawn. So when you draw the histogram, so this histogram, it shows you this is basically the frequency, and these are basically the class interval in the x-axis. The x-axis represents the class interval, and the y-axis it represents the frequency. So in this case, you can see that we have previously seen in this particular slides the different formulae for the calculation of the mean, median, and the mode. In this case, by simply using this graphical representation of the data set, you can calculate the mode from this particular data set. So you have already seen the mode actually represents the class interval, or mode actually represents the data point which is repeated the maximum number of times in the data set. So here, in case of the group data, the mode actually refers to the class interval having the highest number of frequency. So here the class intervals are not written, but let us take, suppose this is 10 to 20, 20 to 30, 30 to 40, 50, 60 like this. So in this case, this particular class interval is having the highest number of frequencies. So that is why it is called the modal class. So when you draw this type of data set in form of a histogram, so you can see that this is the modal class, this is the class, modal class preceding the modal class, and this is the class succeeding the modal class. So like this, from one corner of the bar to this particular left-hand side of this succeeding bar, if you draw a line like this, and again you draw from this particular point to this particular point, if you draw a line like this, so this intersection, the point at which it intersection, it will give you the precise mode of the particular data set. So this is a very simplest way to calculate the data point using calculate the mode value using a histogram. Now, there are the other ways of your observing that whether the data that you are dealing with has how the data is actually spread and how the measures of the central tendency are located away from the individual data point. So this adds up a important value to the measures of the central tendency, which is basically referred to as the measures of the dispersion. So in this case, the range is the simplest term. The range basically refers to the span of the data, and it can be easily determined by subtracting the highest value from the lowest value. So this will give you the span of the data. And this range is clearly affected by even a single outlying value. So that means if there is a single outlying value, it will change the entire range of the data set. So this range is also very important for calculating or determining the class intervals for the preparation of the frequency table. So here you can see that there are different type of the data point. So in this case, there are two different terminologies that we have seen in case of the descriptive statistics. One is the skewness and one is the kurtosis. So in this case, you can see that the same data set, in all the cases, the mean of the sample is same, but the spread of the data is different. So here you can see that this is a little bit, the amplitude is very high. So this is a kurtosis. And in this case, this is properly distributed in both the sides. This is the left-hand side and the right-hand side. This is called left tail and the right tail. So in this case, this data is more tailed towards the right. So this is a right tail data. So that is the spread of the data either on the left hand side and the right hand side. It determines the skewness of the data, and the height of the individual your data point or the spread of the data, it represents the kurtosis of the data point. So that means the same type of data may have different type of skewness and the kurtosis, which can also be determined mathematically. So that means different type of data sets can have the same type of mean. So here it becomes a very difficult in terms of the statistical point of view, that different set of your data, different data sets or different data set collected from the different population can have the same type of the mean. So in that case, it can create some confusion. So that is why it is calculate the measures of the dispersion, basically the variance and the standard deviation also. So that is why in most of the cases, whenever you see some research paper, you will find that the mean value is preceded by the standard deviation or the standard error. So either we do not show the mean value individually. We also give the measures of the dispersion, that is the standard deviation. So here you can see the standard deviation, basically it refers to the individual data point from the central location, that is the mean. So the standard deviation is basically calculated by the calculator as the average deviation of the each and every individual data point from the measures of the central location, that is the mean. So here you can see mean. So here you can see that y is equal to y minus y, that y is equal to y minus y bar. Y bar, it basically refers to the median, so which is basically known as the deviate. So like this, you can calculate the deviation, and then you calculate the average of the deviation, which will give you the standard deviation. So you can see that the standard deviation, I am not going into details. So basically, there is a problem in calculating the standard deviation, is that whenever you calculate the standard deviation like this, that means y is equal to y minus y bar. So this is a deviation. So in this case, you will find that when you add up this deviation, that means summation of the y or summation of d. That means whenever you add deviation, that means summation of the y or summation of d. That means whenever you add up this deviation, it will come to your zero. So it will be very close to your zero. So that is why it cannot give you the meaningful interpretation or meaningful representation of the deviation of the each and every individual data point from the mean value. So as a result of this, we try to perform the statistical interpretation. So this square of the data or summation of y square. So now you can see that standard deviation is basically calculated. What is variance? Variance is basically the square of the standard deviation. And this variance is basically the summation of y square by the n. Here n also represents the number of the observations. So this is the variance. And if you take the square root of this, because you have squared all the individual deviate, so again taking the square root, it will give you the standard deviation. That how the individual, what is the average amount of the deviation the individual data sets are deviating from the your mean value. So that is basically the standard deviation. So you can see there are
we are crossing the time. We are crossing the time limit, so if possible, try to finish in next 5 minutes.
The time is up to 1 or?
No, it's for second lecture, sir. For second lecture.
Uh,
Okay, so this, I think
so
this is the part of the first lecture.
and now I have combined all both of this lecture. So
So can
descriptive
we have
and
a 5 minute break? So when okay,
we can have 5 minute break. No
okay,
problem. So the second part will take a little bit lesser time.
okay, sir.
So so what to do? We can take the break now or?
Yes, sir. We can take a break right now for 5 minute break. Meanwhile, we can take the attendance of the participant,
Okay,
and
no
then we
problem.
will rejoin after 5 minutes. Mean
Okay, no problem, sir.
we
We
all
can.
will be here. Just only we are just having taking the 5 minutes break.
Okay, no problem, sir.
Okay.
Sure.
Thanks a lot, sir.
Okay. Okay.
Meanwhile, participant, you can mark your attendance in the chat message box and be ready with your question. You can, in the end of the both the lecture, you can ask your question or type in the message box. And please do not write your name twice because yesterday we have seen that there are many participants who are typing their name again and again. You have to mention your attendance only twice a day. We are going to restart in next 2 minutes.
So now we are going to start. Over to you, Dr. Swarnendu.
Yes, sir, we can start.
Okay. My screen is visible, na, properly?
Yes, sir, properly visible, sir.
Okay. Okay. Now, what we have discussed is the measures of the central tendency, that is your mean, median, mode, and the variance and the standard deviation. So one consideration that we always have to make during your inferential statistics, you go for the sample mean and the your population mean. So there is a difference in the notation and difference in the understanding of that. For that, often we have to divide that with the n-1. So that is why whenever we want to, as a mathematical statistician, so we have to avoid the bias. And for that, instead of dividing with the n, we need to divide with the n-1 to remove the biasness from the population variance. So now you can just have a look at this different mathematical your formulae for the calculation of the variance and the standard deviations. I will share with you. So you can use it as a reference. So different methods are there: direct method, assumed mean method, and one shortcut method is also there. So now let us come to the how, which is the most important part of in case of the descriptive data. There are two different type of your data sets. You have previously seen that different type of variables are there: nominal, ordinal, which represent the categorical variables, and the interval and the ratio that represent the your continuous variable. In this case, you can see there are different ways of representation. That is, the proportion is there. So there are different ways of representation. That is, the proportion is there. So here you can see that you can display the proportion in the form of the bar charts. So this is one example that children without a recent physical checkup, depending upon the races of the different population. So you can see that the percentage, it can be shown like this. So these are the form of the pie chart. You often have seen different type of representation in the form of the pie chart. The same thing, it can be shown in the form of the pie chart. So this is an representation in the form of the pie chart. Then the line graph. So here one example you can take, that is year-wise death rate. So this can be plotted in the line graph. This is also one way of representation of your data. So this is known as the line graph. Again, you can see that the rate means the rate is basically referred to as the something which changes with the time. So that means the mortality rate or the morbidity rate or the natality rate. So these rates are basically calculated in terms of your percentage, and it basically does not exceed your 100%. Here you can see that one data set is there. So this is basically showing the change in the rate, percentage of the change in the rate, and it is also shown in terms of the your line graph. So that means the method of calculation is different, but the representation is in the form of the line graph. Now again the ratio. So the ratio is basically, it is somewhat different from the your proportion, and this is basically represented as it's the different examples that you can take, that is the disease prevalence and the disease incidence, and these proportions and the ratio are somewhat very similar, but this ratio is calculated in terms of A by B, where what is A and B are similar quantities measured from different groups or under different circumstances. So like this, for example, disease incidence in group 1 and disease incidence in group 2. So this is the relative risk, that how one group is at the higher risk, whether one group is at a higher risk or lower risk from compared to the other group. So this is the ratio. So in this case, you can see that this is the simple plot that can be used as a tabular and graphical method of description of the continuous data. So here you can see these are the different data collected from the different states of the different provinces of the United States, and within the same axis. So you can see there is only one axis, that is the x-axis, which shows the rate per 100 population. So this lowest one, it represents the 393.9 and represents the 1242.1 number of individuals per 1 lakh population. So this is the death rate. This is the crude death rate for the different individuals. So each and every individual, these lines, it represents the data collected from the different provinces of the United. Then the frequency distribution, we have already discussed that preparing the class interval and the frequency. This is the frequency distribution table. And this frequency distribution table, so this is the data set from which the frequency distribution table can be prepared by, first of all, calculating a range, that is the spread of the data, and then using the tally marks like this. That means you can count the number of the data point that are present in between this particular class interval like this, and like this you can calculate the frequency, and accordingly you can calculate the relative frequency in case of the percentage. That means what is the percentage of this particular frequency in terms of 100. So it will totally add up to your 100%. Again, this is the histogram, the same thing, the same class interval. That means if you can take the class interval in the x-axis and the frequency on the y-axis, you will get a graphical representation polygon. So these are the different ways of representation of the data. And this is a very important, this is a very interesting representation of the data point in case of the continuous data, is that which is known as the stem and the leaf plot. So you can see that these are the stem and the leaf plot. So in this case, you can see that two different groups are there, males and the females, and the systolic blood pressure. So this is the blood pressure of the male and the females. So number of the male and the female are different, but you can see the numbers 100, 104, 105. This represent the blood pressure, systolic blood pressure readings of the males and the females. Now, basically the stem, it represents the common values. So here the stem, you can see 10, 11, 12, 13, 14, 15. Like this represents the stem. And in one side, you represent the values of the males. And in one side, it represents the values of the females. So here you can see there are three individuals which are having the three males which are having the blood pressure in this particular range, that is 100, that is 100, 104, that is 104, 105, that is 105. So that means in this particular plot, though it is very simple, the tabular representation, though it is very simple, but you can get to know about the each and every data point that you have collected. So that is the interesting thing of this particular representation, that is the stem and the leaf plot. Now the cumulative frequency, already have seen the frequency table, which shows the relative frequency in terms of 100%. And in case of the cumulative frequency, you just add up this particular frequency with the succeeding frequency. So this cumulative relative frequency, it also adds up to your 100%. Now this is the plot line graph, which can also be plotted with the cumulative frequency table, and it will attain a stationary phase at the 100% mark. So this is the representation of the median in case of your percentile representation of the median. So 25% already we have discussed, that is represent the Q1. Q2 is the 50%, which represents the median. So if you can plot a line towards the x-axis, you can get the median like this from the line graph. So this 75% mark, it represents the Q3. And the difference between the Q3 and the Q1, it represents the interquartile range. Okay, so this is all about the your descriptive statistics, how you can perform the numerical analysis using the different descriptive statistical tools like your mean, median, mode, standard deviation, and variance, and how you can represent the data point or the data set in terms of a tabular and graphical representation. So now let us come to the inferential statistics. We have already discussed in the previous slide, or at the very beginning, we have already discussed that how the descriptive statistics and the inferential statistics, they differ from each other. So the descriptive statistics, it is a very crude description of the data point. So that means it tries to simplify the data point. It tries to give you some value which can represent your entire data point. And it tries to give you some way or measures by which you can show or represent or visualize your data set. In case of the inferential statistics, the descriptive data in such a manner that it can give you an indication that whether the data point has some meaningful interpretation, whether the measures of the central tendency, mean median mode, or the standard deviation has some meaningful interpretation, and it tries to assume, or it tries to draw a meaningful interpretation regarding the population from the sampling unit. So here you can see that there are different measures by which you can do inferential statistics. That means you can directly estimate the parameter, you can go for regression analysis, you can go for the determination of the confidence interval and the hypothesis testing. So this confidence interval or the p-value is important, because the p-value, determination of the p-value or the hypothesis testing is very, very important to actually signify or to actually derive that whether the whether the description that derived from the data point is meaningful or not, or whether whatever assumption you have made about the population using that particular analysis is significant or not. So that we can do with your inferential statistics. So mostly we will be focusing upon the hypothesis testing and the confidence interval. And regarding the hypothesis testing, this is also known as the statistical significance testing. So the purpose of the statistical significance testing is basically to answer the following questions. So what are these questions? That can the observed results be attributed to the real characteristics of the classifiers under scrutiny? Okay, so whether the whatever information that you have regarding the data set, it can give you some meaningful interpretation or not, or whether you have this not by any chance. So that is unbiased, and the result that you have got is not attained due to some chance factor. Also, whether the data sets, they represent the problems which the classifier will be applied in the future. So whether the data sets or whether the sampling be applied in the future. So whether the data sets or whether the sampling has been properly done or not. So that has been properly done or not. So that can be inferred with the help of the statistical significance. That can be inferred with the help of the statistical significance testing. So the testing. So the important point is that because the inductive nature of the problem, such questions cannot be fully answered. And the user should instead accept that no matter what evaluation procedure are followed, they only allow us to gather some evidence into the classifier's behavior. Okay, so that means in most of the cases when the information is very less, so to make sure or whether the data has been properly interpreted or not, the statistical significance testing is very important. And the currently applied statistical significance test is basically dependent upon the rejection of the null hypothesis significance testing. So this null hypothesis significance testing is very important. So this is also in short form is known as your NHST. So the basic objective of the statistical significance test is to formulate a null hypothesis, and it aims to reject the null hypothesis due to the fact that it is commonly misinterpreted, causing overconfidence in the meaningless result. So that means our objective of the statistical significance testing is actually based on rejection of the null hypothesis. So before going further, let us first discuss that what is the terminologies I will be discussing, that the parametric approaches and the non-parametric approaches. So the parametric approaches, it is basically referred to the population, that means which makes a strong assumption about the distribution of the population. So this is the parametric approach, and the non-parametric approaches are basically not directly, they cannot infer a direct interpretation regarding the population, and their assumption is not as strong as the parametric approaches. So the parametric test, this is basically referred to the population parameters. So that means the parametric test is the one which has information about the population, whether the non-parametric test is the one where the researcher has no idea regarding the population parameters. So that means when the population parameters are known, in that case, the parametric tests are performed. When the population parameters are not known, in that case, you have to perform the non-parametric test. So this is the basic distinction between conducting a parametric test, which calls for the application of the parametric model. And if you are dealing with the non-parametric test, you have to go for the selection of a non-parametric model or the non-parametric statistical tools. So you can see that this is a comparison chart between the parametric test and the non-parametric test. In this case, the distribution is known. In case of the non-parametric test, distribution is unknown. So that is why you can calculate or you can do the significance testing using the mean value. But in case of the non-parametric test, you have to perform the significance testing using the median value. So in case of the parametric test, the population parameters are known, but in case of the non-parametric test, the population parameters are not known. One important distinction is that in case of the correlation test, the Pearson correlation test is performed in case of the parametric dataset, and the Spearman rank correlation coefficient or rank correlation test is performed in case of the non-parametric test. Now already we have discussed that in case of the normal distribution, when the population parameters are known, we perform the parametric model or the parametric test. So this is basically the normal distribution, which appears like a bell-shaped curve. So this is the symmetric curve having the equal skewness on both the sides. So this is the left-handed side and the right-handed side. So this is symmetric in nature. So this is basically the normal distribution where ideally the mean and median and mode should overlap with each other. So this is the ideal condition of a normal distribution curve. But basically when we conduct the data distribution table or the when we do sampling and the survey, ideally the mean, median and the mode, they does not overlap all the time. They may be close to each other, but in totality, they may not be overlapping. So I'm not going to details of the non-parametric test. So basically, the rule of the thumb is that whenever you have an interval or the ratio scale, that means when you have some numerical attributes, we go for the parametric test. And whenever we are dealing with the nominal or the ordinal scales that we have discussed very at the beginning, that nominal and the ordinal scales, they represent your different categorical variables. In that case, you have to perform the non-parametric test. So this is the hierarchy of the hypothesis test. So this hypothesis test, it varies for the parametric and the non-parametric test. So in case of the parametric test, you can see that there are a different type of the hypothesis testing. So one is your one sample parametric test and two sample parametric test. In case of the one sample parametric test, you can perform the t-test and the z-test. So these are the different statistical tools that you can use for the parametric test. And in case of the two sample parametric test, there are two different types of the two sample test. One is your independent samples and one is a paired sample when the two samples are paired with each other. So in this case, the paired sample t-test, paired t-test is actually performed for the paired samples. And in case of the independent samples, we can perform the two group t-test and the z-test. Here also the z-test can be performed, but the manner in which the Z score is calculated may be different. That means the mathematical formula can differ from each other. In the similar way, in case of the non-parametric test also, the one sample test and the two sample test, they differ from each other. Here you can see the example of the one sample non-parametric test. The examples are chi-square test, Kolmogorov-Smirnov test, runs and binomial. So there are different other tests also. These are some of the reference examples that have been shown in this particular slide. And in case of the two sample test, you can see that the paired samples and independent samples. In case of the independent samples also, you can perform the chi-square, the median test, the Kolmogorov-Smirnov test, and the Mann-Whitney test. So these are the different tests. And in case of the paired sample, you can perform the sign test, Wilcoxon test, and McNamara and the chi-square test. So this is a basic outline of the different tests that can be conducted depending upon whether the sample or whether the data is parametric in nature or whether the data is non-parametric in nature. So if there is only one variable or one...
Excuse me, sir. Can you explain the McNamara test for I really want to?
Which one?
Sir, McNamara test.
McNamara test, these are basically the different tests. Okay, so these are the different tests and they are performed for the paired sample t-test. Okay, they are having the different, actually, they are having the different type of your formulae. Okay, so I have not included those formulae, they are a little bit complex. The only thing is that they are non-parametric in nature. Non-parametric in nature means that means they are either they will be in the nominal scale or the ordinal scale. In case of the paired sample, whenever we are concerned about the paired sample, suppose you want to see the effect of drug on two different populations. Okay, so in that case, paired sample means that means the effect of the drug dosage is common to the both the population. So whether the population is behaving in a similar way, whether the population is behaving in a similar or responding in a similar way to the effect of the drug, that can be tested by using this particular tool. So these are the different tools: the sign test, Wilkinson, McNamara. Okay, so these are the different statistical
Yes,
tools.
sir. Thank you.
And we will, sir, sorry to interfere. We will cover them in the details in the upcoming session. We have a separate lecture on test of hypothesis and other tests. So this query can be asked at that time because it's the first class, the second day only of this certificate course. So I stopped sir in between to not to go in the detail. Otherwise, it will be too much for the beginner.
Huh. So I would just wanted to show you that what are the different conditions or what are the different situations in which you can use the individual test, because most of the times we are not aware that which particular test should be conducted for which particular data set. So that is the thing. So for that we have to understand that which type of hypothesis test should be conducted for which type of data set. Is it clear?
Yes, and for each test we need a separate lecture.
Separate
So
lecture.
yeah,
That is itself a separate lecture, each of the test.
yes.
Okay.
Or we can do one thing. If the participant want a specific query, they can write us, and we will directly mail it to you so that you can give the explanation through email as well.
No problem.
Okay,
Some
sir.
of the tests and some of the examples I have added at the end of my presentation.
Okay.
Mostly the t-test, jet-test, and the chi-square test, which are most commonly performed actually. So this
Yes.
McNamara, this Man-Whitney, they are highly specialized tests, and they are most of the times they are not performed for the. We do not use need not use this test for most of the times.
Yes,
So
they are not
whatever.
very common test.
These are not very common. So the most of the common tests like your jet test, t-test, sign test, chi-square test, I have included some slides with examples at the end of the presentation. So you can have a look at that and you can get an idea about that, in which circumstances this particular test need to be conducted and what are the significance of conducting this particular test. Okay, so let us come to the hypothesis, that is, which is the most important part of this significance testing. So that means the hypothesis testing is the very central core to the your inferential statistics. That means whenever you want to conduct some hypothesis testing, you need to formulate a hypothesis at the very beginning of the test. So this hypothesis, in literal term, it means these testable statements about the world. So that means whatever data set you have, here the world means the sampling unit. Whatever interpretation that you want to, that means you should have a prior idea about the interpretation of your data set. So in that case, you can formulate a testable statement and you want to prove this particular hypothesis as falsifiable. So in that case, this particular hypothesis is known as the null hypothesis. Here you can see that if you want to test the hypothesis by attempting to see if they could be false rather than proving them to be true. So in that case, there are two types of hypothesis. One is the null hypothesis and the alternative hypothesis. In most of the cases, the null hypothesis, it represents a hypothesis is formulated in such a way that it has to be rejected, or it maintains a status quo, or it is a negative statement. So that is why it is known as the null hypothesis. For example, here you can see one example that all swans are white. So Popper said you cannot prove that all swans are white by counting the white swans, but you can prove that not all swans are white by counting one black swan. So this is an example. That means if you formulate a hypothesis like this, null hypothesis, that all the swans are white in color. So that means if you count only the white swans, so it will not prove your statement false. Only if you find one black swan, it can prove your statement false. So that is why the hypothesis formulation is very, very important. So in this case, we normally generate a hypothesis from the combination of the theory. That means we have a theoretical knowledge, we have some assumption regarding the population. Dependent upon that, we formulate a hypothesis in such a way that it can make a hypothesis in a testable format. So that is why this hypothesis is basically referred to as the testable statements. So there are two different type of hypotheses. One is your descriptive inference. For example, the old people are more religious than the young people. And the causal inference, that means old people are more religious than young people because they think about death more. So if you compare both these hypotheses, So descriptive inference does not tell you the particular reason of that particular statement. But in case of the causal inference, you also have the reason, the probable reason for this particular statement. So that is the basic difference between the descriptive inference and the causal inference. And we test the hypothesis using the significance testing. So already I have shown you the particular chart that what are the different tools for the significance testing. So in this case, there are two hypotheses that were formulated at the very beginning of conducting the hypothesis testing. One is the null hypothesis and one is the alternative hypothesis. So what is null hypothesis? We can see the null hypothesis is a statement that the parameter we are interested has a value similar to no effect. So that means we always formulate the null hypothesis in such way that it represents the negative impact or it shows no effect. So that is basically the null hypothesis. For example, regarding the religiosity, old people are same as young people. So these are the examples of the your null hypothesis. Or another example we can take that the mean value is not significant. The differences in the, if there are two sampling units, we can say that there is no significant differences between the mean value. For example, the example that I have told a little while ago, that the effect of two drugs, effect of a drug A and effect of a drug B in the population. So you can see that if in case of the two drugs, the effect can be either there should be a significant effect or a non-significant effect. So the null hypothesis to be formulated is that there is no effect of the two drugs on the individual. So that is a null hypothesis. And what will be the alternative hypothesis? Alternative hypothesis is just the opposite of the null hypothesis, which contradicts the your null hypothesis. So this is a statement that the parameter falls into two different sets. So what will be the alternative hypothesis for the example that I have discussed? That there is a significant effect of the two drugs on the population. So this is the just the opposite of the null hypothesis. So that means whenever you formulate a null hypothesis, the formulation of the null hypothesis is very, very important. And after that, the alternative hypothesis is easily formulated because it is just the opposite or vice versa of the null hypothesis. So you can see that depending upon the distribution, there are two-sided alternative hypothesis. That means mu is equal to 50 centimeter per second, that is your null hypothesis, and mu is not equal to 50 centimeter per second, that is your alternative hypothesis. If you see this in this type of your graphical representation, you can see that this is the region of the null hypothesis and this is the region of the alternative hypothesis. So the p-value, it is most important. So most of the time you have seen that in the case of a significance testing, we take a p-value of 1% or 5%. So what is 1% or 5%? So let me explain with the help of this type of distribution table. So this is the normal Bell separate distribution table. This is the left tail side, and this is the left tail, and this is the right tail. So this is the two tail test. And when you are concerned about only the right hand side, this is known as the right tail side. And when you are concerned about the left hand side, this is the left tail side. So you can see this is rejection, and this is the region of the acceptance region. So if you get a value in this particular region, what will happen? The null hypothesis will be accepted. And if you get a value in this particular region, the null hypothesis will be rejected. So depending upon the statistical tool, whenever you get a correct conclusion, so in that case, the rejecting the null hypothesis, rejecting a true null hypothesis can be there. So in that case, it represents the type 1 error. So in certain cases, you can accept a false null hypothesis by accident or by chance. You can accept a false null hypothesis that can represent your type 2 error. So this type 2 error is not applicable in case of your statistical, in case of our hypothesis testing. In most of the cases, the alpha value or the p value is actually required. So which represent type 1 error is actually represented by the alpha. So this is basically the confidence interval. You can see that this is the rejective region of the rejectable null hypothesis. This is the region of the rejectable null hypothesis. And in between, this is the region of the acceptable null hypothesis. So whatever 1% and 5% I am telling, so that means if you are taking 5% value, so it will represent a larger region for the rejection of the null hypothesis. If you are taking 1%, this particular region will decrease. So that means acceptance region will be increasing. So this is basically this depends upon the confidence interval. And it also depends upon the p-value, whether you are taking a p-value of 0.05, 0.01, or 0.001, which represents 95%, 99%, and 99.9% of the confidence interval. So you can see that p-value, either this type of representation you will find in case of the statistical analysis, that is p less than 0.05, which is actually synonymous with the 95% confidence interval. So you can see this is a chart. This is the outline of the chart, which shows you the different types of the hypothesis when you have the mean values. That means whenever you want to test for the mean value, you can, if you have one mean or two means, that means one mean means one sample, and two means means you have two different data sets. So in this case, you can use the different type of your statistical tool. That is your Z distribution, T distribution. The formulas are also there. You can see, and here also Z distribution and T distribution. And in case of the proportion also, you can perform the Z distribution and the chi-square test. So you can see, so this slide include the different tests, and the example problems are also there. So you can go through this, and you can easily find out that what is the practical application of this particular test in conducting the significance testing. So you can go through this. Some of the tests I have included: Z test, one sample T test, then paired sample T test, then your independent sample T test, and the chi-square test. So these tests have been included. You can go through, and if you feel these slides are very self-explanatory, so you can go through this. They are very easy to understand. So you can go through this, and if you feel any difficulty, you can write back to me. So with this, I would like to finish my particular presentation here. And if you have any questions, I will be happy to answer. Thank you.
Wow. एक्चुअली दिस इज नोन एज गागर में सागर. एक कहावत सुनी है हमने, गागर में सागर. So it was an honor to have Dr. Roy, and the way he shared his invaluable insight.
The pleasure is mine, sir, because the topic is so broad. So
Yes, but you tried, you give it a best effort. The one can have from the beginning that what is the basic definition of the descriptive statistics and the inferential statistic, and you have touched each and every part of them. But yes, we can understand there are many first year students, for them it is actually too much. But I assure you on behalf of the organizing team that don't worry. If you are new to this subject, we are going in the detail of each and every topic sir have touched. So his lecture is actually the soul, or you can say it is summary of the 50% of our certificate course. So in the coming next 3-4 weeks, what we are going to learn, it is the summary of that. So it was like watching a movie where we have where we seen the beginning of a story, and you have come up to the end, up to your parametric, non-parametric test and everything. You even explain the p-value, chi-square, null hypothesis, each and everything. We understand that it is not easy to understand for the beginner, but yes, as I told them that we are going to touch all these topics in the details in the coming session. Now, this platform is open for the question. Let me see if there is any question in the chat box. Yeah. Okay. So Shashank's question is, sir, can you explain anti-modal stem and leaf plot one more time?
Okay. So anti-mode is basically, that the mode is actually the value or the class interval which has the maximum number of frequency. So that means any type of value which is represented the most number of times in a data set is basically the mode. So in certain cases, what happens that in case of the multimodal data means suppose there is one data set like 1, 2, 2, 2 is repeated 3 times, then 5, 5, 5, it is also repeated 3 times. In that case, there are 2 modes in that particular data set. That means 2 is repeated 3 times, 5 is also repeated 3 times. So in that case, when you draw a frequency table like this, so you will have 2 different peaks. One is at your 2 and one is at your 5. So maybe the region between the 2 and the 5, it will show a depression. So that is basically the reverse of the mode. So that particular depression is basically the anti-mode value. I hope it is clear.
Shashank, I hope it is clear to you as well and for everyone. Shivani Pal what she is asking, sir, can you explain confounding variable again? Confounding variable, sir.
Confounding variable. So
Yes.
basically, the confounding variables are the variables which can affect your experiment knowingly or unknowingly. Okay, the example that we have taken, that is the effect of caffeine on the memory. So in that case, the confounding variables are that means you have only taken the variable in terms of the maybe the number of cups of coffee that you are consuming. So in that case, you have not taken the concentration of the caffeine or the time of the day at which you are consuming the caffeine. It can also have an effect unknowingly on the outcome of the result. So that are basically the confounding variables.
Okay. Is there any question? No. Okay, sir. Sorry, I'm just acting as a dealing for that. You have mentioned that we should use n minus 1 instead of n in a formula to determine the standard deviation.
Yeah.
But I don't know, it may be because of typographical error. In your slide, it was showing in when you are calculating, when you are showing an example, it was showing the denominator as n instead of n minus 1.
Yeah. Actually, the thing is that basically what the statistical books they prescribe is that whenever you have a data point more than 30, so in that case you can use n minus 1. But it
But
is not all. It is not always true because if you are dealing with only the sampling unit, so in that case you can divide by if you are only predicting for the sampling unit actually you can divide by n. But if you are going for the significance testing and if you are going to predict for the population, in that case it is to avoid the bias actually you have to divide by the n minus 1.
yes, and I think all the software, whether it's Microsoft Excel,
Ah,
SPSS, or R, they are using n minus 1 instead of n. And all
n.
the standard books.
Ah,
Okay, sir, there is one more doubt where I written. Yes. So it says learning for all of us that the terminology used in statistics should be used very carefully. Like
ah,
sir used whenever he used to determine the median value. So instead of calculating, sir always mention locate because median and mode are the position of average of position. So we
position.
cannot calculate. We have to locate that position.
Ah,
So we should take care of these things. For this is for all the participants, that whenever we are determining the median value, actually we are locating that median value. We are not calculating it.
ah.
So these are the minor things which I have noted down. Yeah, that's it. So let's. If there's any doubt, you can ask. You can raise your hand or type in the text box. Okay, I think there is no doubt. And if you we are uploading all the videos in YouTube channel, college YouTube channel, and in case you have any doubt, you can write in that video link so that that question will directly taken by our speaker. We will share the link of that YouTube channel to our speaker, and they will answer there itself. So Jishan sir, I think now we can end this today's session.
If the participants are want the PDF of the presentation, I will share with you.
Yeah, it will be
So
a great help, sir. It will be a great help, sir.
uh, you can
Yes,
share
sir.
with
Thank
them
you.
because many of the aspects are included. They can go through and practically they can practice the problems also if they want.
Yes, sir. Yes, sir. That will be a great help.
Yes, sir. Thank you
Jishan
very
sir?
much, sir. And even our participants have also requested in our chat box that they wish to get the your PPT maybe in PDF form or in PPT form. So that will be very helpful. So when they are going to solve their assessments, because it can be useful to get revision when they are going to do their assignment. So with all these things, I think if any participants wish to interact with our speaker, it will be very nice. So please don't hesitate. If you won't have any doubt, don't feel that it would be silly or anything. You can just raise your hand, we can unmute you, and then you can discuss it. So don't hesitate. You can interact with our speaker. This is one time chance. Okay, so I think nobody wants to say something. So with these words, I think we can propose a vote of thanks. So Dr. Swarnendu Rai, we are very thankful that you spare your valuable time, that too also on a weekend.
Excuse me, sir.
And
Excuse me, sir. Jiswan sir,
yes, sir.
your voice is breaking. At,
Okay, okay.
so, can I take this opportunity to thank our speaker?
Please go ahead.
Okay, okay, sir. Because your voice is not clear, so I don't want a breaking in the vote of thanks. Sir. Sorry for the interruption. So now the session is about to end, and it's time for to thank our speaker, Dr. Swarnendu Roy. So, on behalf of the organizing committee, I take this opportunity to express my heartfelt gratitude to all those who made this event a success. First and foremost, our sincere thanks to Dr. Roy for gracing the occasion with his presence and sharing such valuable insight. We are truly honored. I extend our deep appreciation to our principal sir, Professor Narendra Singh, whose guidance and constant support made this program possible. To the IQAC coordinator, Professor P.K. Sisodia, and the bursar of the college, Professor Mukesh Jain, thank you for your constant support and guidance. I also acknowledge the constant effort of the convener SDCC, Dr. Saima, and fellow colleagues, Professor Dheeraj Singh, who ensured the smooth conduct of the session. A special thank to all the participants who have registered and shown such enthusiastic engagement. Your presence is what gives meaning to this course. Yes, we are unfortunate that some of our participants are unable to join through the direct meet, but I hope you have learned through the YouTube, and you can ask your query YouTube whether you have joined through Meet or you are joined through YouTube. Your question will be taken definitely. Last but not the least, thank you all once again for being with us today. We look forward to continued learning, collaboration, and success throughout the course. Thank you, everyone, and we will see you in the next week. Thank you. Thank you so much, sir.
Thank you very much. Thank you.
Participants, please leave the meeting.
सर आपकी
Participants, please
माइक्रोफोन
leave the
ऑफ
meeting.
करें.
All the participants are requested to please leave the meeting.